Hey everyone, in this lesson we're going to be talking about how do we solve quadratic equations by using the method of completing the square. So before I go into what that method is, let's review about all the different methods that we have for solving quadratic formulas, starting with the easiest and then working our way up. There's actually 4 different methods in total. The first method is by factoring and by using at the same time the zero product property. So you can factor everything out, with the x or whatever, the box. Use the zero product property and then solve each equation to figure out your total roots. The second one is by using square roots. So if you guys have something in terms of square roots, you can move everything to one side, take square roots, and then you can solve the quadratic equations by the method of square roots. The third one, which is what we're going to be talking about right now, is by completing the square. So completing the square, and I'm going to put a little underline here because this is what we're going to be talking about today. And the last method, which will be the last way to solve a quadratic equation, is with the quadratic formula. So quadratic formula. And we'll talk about what that is in the next lesson. But for right now, we're going to be focusing strictly on completing the square. What does that mean? And how do we solve quadratic equations with the method of completing the square? The last two are useful. Number 3 and number 4 are useful because it allows us to solve any quadratic equation, regardless of whether it's factorable or not. And I'll explain that with the first example. So let's say, for example, we wanted to solve this quadratic equation, right? So in this case, we have x squared plus 2x plus 2x minus 2 is equal to 0. We want to solve that, but notice that this one cannot be factored by using the x. If I try to use the x, I'm going to put negative 2 on top and then 2 on the bottom. I want two numbers that multiply to the top number but add to the bottom number. The combination of those two numbers would be 2 and 1, right? But the problem is, like, if I make one of them negative, this adds up to a negative 1. And if I make the other one negative, this adds up to a positive 1, so it does not work. So this is actually not factorable, which is the problem. So how do we even go about solving for something that is not factorable? And that is where number 3 and number 4 come into play, completing the square and the quadratic formula. Today we're going to be talking about how do we solve quadratic equations by completing the square. So essentially what that is wouldn't it be great? Let's start with this. Wouldn't it be great if the quadratic equation looked more like this? So rather than it looking the way that it did before, it was x squared plus 2x minus 2 earlier, right? So we had a minus 2 here on this part. However, wouldn't that be great if that was just plus 1? And the reason why I say that is if we have x squared plus 2x plus 1, we're actually able to do the x, right? Factor it. We put a 1 on top. We put a 2 on the bottom. We want two numbers that multiply to the top and add to the bottom. That those two numbers would actually be positive 1 and positive 1, right? Because 1 times 1 is equal to 1, and 1 plus 1 is equal to 2. So the reason why this is called completing the squared is because if you notice, we're actually getting a perfect square of those two numbers, meaning like that number times that number by itself, right, would give you the original problem that we had. So in this case, when we simplify this out, x plus 1 multiplied by x plus 1, that would give me x plus 1 all squared. So why am I talking about this? How does this even help us in the first place? So all that completing the square is actually turning something that is not factorable into turning something that is factorable. And it's not really that hard to do so if you think about this as right now it's a positive 1, right? So it's x squared plus 2x plus 1. However, we wanted it to be x squared plus 2x minus 2. It shouldn't be that hard to convert that positive 1 into a negative 2. All I have to do to convert that positive 1 into a negative 2, I have to just subtract 3. And since I subtracted 3, I basically have my original problem to begin with, right? So the only thing I really need to add to this is just a minus 3, and I have my original problem. Well, this is called completing the square because it allows us to get a perfect square plus something else. And then if you have a perfect square plus something else, you're able to solve this by using square roots, which we talked about in the last lesson. So that's all the completing the square method is turning something that is not factorable into something that is factorable. And I'm going to show you guys how to do that consistently in this lesson, so you're able to do basically any problem that has the a equal to 1. So, okay, let's say I wanted to solve this, right? So I would draw the wall, add 3 to both sides, add 3 to both sides. I get x plus 1 all squared is equal to positive 3. I have to take the square root of this side, so I can leave the x plus 1 by itself, and I have to take the square root of this side. On the left-hand side, I'm going to be left with x plus 1. On the right-hand side, I have a plus and a minus, don't forget, the square root of 3. And then all I have to do now to be able to solve this is split it up into 2 equations. So my first equation would be, you can break it up now or you can break it up later. It really doesn't matter. You can say x plus 1 is equal to positive square root of 3. And you can say x plus 1 is equal to negative square root of 3. If you solve each one of these equations, you get the final answer. So the final answer will be x is equal to negative 1 plus square root of 3. That's one of my answers. And the other answer would be x is equal to negative 1 minus the square root of 3. So when we get the x by itself, these are my two answers. And the reason why we weren't able to think about, the number that added to this but multiplied to that is because these are actually decimals. When you pop in square root of 3 into the calculator, so 3 square root is 1.73. So if I add 1 to that, that would be 2.73. And if I subtract 1 from that, I would get does whatever other number that you get originally. It was negative 1 minus square root of 3, right? So let's see, square root of 3, make that a negative, and then minus 1. So it's negative 2.7 or whatever. Anyways, so the point is, it's decimals, and that's the reason why we weren't able to think of those numbers right away. So this is the example in which you're going to have some decimals as your answers, and that's where completing the square comes into play. So you've done this before. These really quick exercises are just to let you guys know that you've done this before. So look at what happens when we have like two things on the outside that are the same thing, right? So x plus 2 multiplied by x plus 2. It's kind of written weird, but it's the same thing. So x plus 2 multiplied by x plus 2. We get x squared, 2x, 2x, and then on the very, very end of it, we get 2 multiplied by 2, which is 4. So you'll see a pattern in a little bit, right? Let's say we have x plus negative 3 or x minus 3 on each side. So you get x squared, negative 3x, and then on the very bottom right, I get positive 9 because negative 3 multiplied by negative 3 is positive 9. If I keep going, you should see a pattern now. This will be 4 times 4, which is 16. This last one will be negative 5 times negative 5, which will be 25. So essentially all we're doing is we're multiplying the two numbers together that are in the diagonal, right? These two numbers, and that'll give us the bottom right of the box. So we're going to need to use this in a little bit because that's exactly one of the steps when using the completing the square. This is actually completing the perfect square as we speak. So these are the steps. I'm going to pause for a minute after this quick definition. So completing the square is a method for factoring quadratics by separating the equation to the sum of a perfect square and a constant number. This allows us to solve the quadratic equation by method of square roots. This is what I explained earlier. This is what it looks like in a nice little diagram. So x plus b over 2, x plus b over 2, and then that little square is you're actually completing that into making it a perfect square by taking b, the middle term, dividing it by 2, and then squaring it. If this looks confusing, forget about it. Let's just look at the steps. So steps are the following. Step 1, we need to make sure that the a is equal to 1 for you to use the method of completing the square. And we need to make sure the quadratic equation is in standard form. So you've seen this before, right? So the quadratic equation in standard form is actually this. It is ax squared plus bx plus c. So all it's saying is that we got to make sure that this number is 1. And then once you're sure of that and it's in standard form, like in order from highest power to lowest power, then you're good to go. Second step, after it's set equal to 0, you have to move all the x's, all the terms without x's to the other side. So terms without x, move it to the other side. Step 3, we're going to draw a 2 by 2 box, place x squared on the top left. You're sure to be used to that. Place b divided by 2. So whatever that b term is, b, we're going to take that number and divide it by 2. and then place it in the diagonals of the box, along with an x. Step 5 is what we just did in the exercises, complete the perfect square. And then step 6 is solve it. So that's it. Write the steps down and it'll make sense once we do more examples in a little bit. So example number 1, and I'm putting this example because I know that you guys can do it by factoring, so we're just going to verify to make sure that completing the square actually works. So let's do this 2 methods. The first method is going to be by factoring, and the second method is going to be by completing the square. So I'm going to make a little column. Okay, and we're going to do this by factoring and then by completing the square. And the reason why this is able to be done is because this is actually factorable, meaning that we actually get whole numbers as our roots. So let's say I wanted to solve this, right? So x squared minus 10x plus 9 equals 0. I would draw the big X, right? Draw the X. On top, I would put a positive 9. On the bottom, I would put a negative 10. And then I want two numbers that multiply to the top but add to the bottom. The combination of those two numbers will be negative 9 times negative 1. Negative 9 times negative 1 will give you positive 9. Negative 9 times negative 1, plus negative 1 will give you negative 10. So my two factors, easy peasy, right? It'll be x multiplied by x equals 0. On this side, I get negative 9. On this side, I get negative 1. When you solve this, you should be really used to this by now. X is equal to 9. That's one of the answers, and x is equal to 1. That's my other answer. Easy peasy lemon squeezy. The left-hand side is done. Now we're going to do the exact same thing, but we're going to do it by completing the square. And the reason I want you guys to do it by completing the square is because sometimes you're not able to factor it, so you're kind of stuck with completing the square. So let's do it by completing the square. Same exact problem. So we're going to be, first of all, step 1 says, make sure that it is in standard form and that a is equal to 1. So that is a is equal to 1 and it's in standard form, so we're good to go. Okay, so step 2 says that we have to move everything that doesn't have an x to the other side. So basically, everything that doesn't have an x, which is a 9, move it to the other side. So I'm going to go ahead and do that. X squared minus 10x is equal to negative 9. Or actually, you know what? Let me not skip that step because I feel like I'm going to lose someone out there. So I have this. I'm going to move the 9 to the other side so I can follow step 2, which says that everything should be moved to the other side that doesn't have an x. So now we're left with this. Okay. Everything else is steps 3. I think we're on step 3. Yeah. Step 3, 4, and 5 basically are the same over and over and over again. We're going to have to draw a box to figure out, okay, what is a perfect square for these terms? On the left-hand side, top left of the box, we're always going to put the first term, which is x squared. In the diagonals of the box, I'm going to be taking this number and dividing it by 2 and putting an x in front of it. So whatever number that is, in this case, the number is negative 10. So half of negative 10 is negative 5. So I'm going to put negative 5x here, negative 5x there. So I'm splitting it, right? Cutting it in half, dividing it by 2. Next, I want to figure out, okay, what goes on this corner? Well, for it to be a perfect square, if you remember from the exercises that we did over here, right? For it to be a perfect square, all we need to do is just take that number and multiply it by itself. That's in diagonal, and we get the perfect square. So that's exactly what we're going to do here for the example. We're going to take this number, negative 5 times negative 5. That's going to give me 25, which is a perfect square for this. That means that if I want to make this factorable, I have to add 25 to this side for it to be a perfect square. So that's exactly what I'm going to do. So plus 25 here. However, I can't just pull 25 out of my butt and just add it out of nowhere. I have to keep the equation balanced. So whatever I do to the left-hand side, I have to do it to the right-hand side as well. So in this case, I'm going to add 25 on this side as well. And there you go. You have completed the square. Once you factor out the box, once you factor out the square, then you have your completed perfect square. So when I factor out the box here, I take an x from this row, I take a negative 5 from this row, I take an x from this column, and I take a negative 5 from this column, and I have my perfect square, right? So this equation, that crazy equation on the left-hand side, just becomes x minus 5 multiplied by x minus 5, which is that the outside of the box here, and I'm going to be setting it equal to negative 9 plus 25, which happens to be 16. If I simplify this further, I know that this is a perfect square, right? So I can actually put a square on top of it. So I can rewrite this as x minus 5 squared is equal to 16. I can solve this now by using square roots. So if I take the square root of this side and I take the square root of this side, I'm left with x minus 5 is equal to plus or minus the square root of 16, which happens to be plus or minus 4. Now, if I want to get the x by itself, I would just draw the wall, add 5 to both sides, plus 5 plus 5. Don't come my like terms yet. So I'm going to be just moving it. So this will be 5 plus or minus 4. So there are two answers for this. My two answers are x is equal to 5 plus 4 and x is equal to 5 minus 4, which if I simplify this, right, x is equal to 5 plus 4, which gave me the first answer as x is equal to 9. If I split this into the second equation, x is equal to 5 minus 4, which gives me x is equal to positive 1. And whoop-de-whoop is the exact same answers that we got by factoring. So you're probably asking yourself, what the heck? Why would I do it by completing the square when I could just factor it? Well, the answer is you don't have a choice. The reason why we use completing the square is when we have something that is not factorable. So that is when we actually use completing the square. Now that I proved to you guys that it actually works, we're going to be doing 2 more examples by the method of completing the square so you can get the steps down. And then basically you can do the 10 example problems on your own. So example number 2. This time we're only going to be using it by completing the square because this is actually not factorable. You can check it yourself if you want. I'm not going to waste time doing so. Step 1, we have to make sure that this is in order and this is in standard form, which it is not. So this is not in standard form. So I'm going to go ahead and rewrite this as x squared minus 2x minus 4 equals 0. Right? Now that I have this in standard form, I know that this is A, this is B, and this is C. So make sure that if it's not in standard form, make sure you fix it as step number 1. Okay, next thing we need to make sure of is everything, or actually we need to make sure that the A is equal to 1, which it is. Since A is equal to 1, I can keep going. The next step says I have to make sure that all the numbers without x's are moved to the other side. In this case, that will be the 4. I'm going to move the 4 to the other side. And I'm going to be leaving the left-hand side with just the x squared minus 2x. And on the other side, I'm going to be left with just a positive 4 plus 0, which is positive 4. Okay. Then I can actually figure out, okay, how can I turn this part into a perfect square? So I would have to draw a box, right? Hint, perfect square. On the top left-hand side of the box, I'm going to put the x squared. Here I'm going to take the b term, which in this case is negative 2, divided by 2. Don't forget you got to cut it in half, and put that on each side of the diagonal. So in this case, I would get negative 1x or negative x, and I would get negative 1x on this side also as negative x. Okay. Then on the bottom right-hand corner of the box, I got to figure out what is negative 1 times negative 1, which will give me a positive 1. So this will be my perfect square. When I factor out the box, I basically have to take as much as I can from each row and each column. On the bottom, I can take out a negative 1. Here I can take out an x. First column, I can take out a x again, and here I can take out a negative 1. We have a perfect square, obviously, right, because we just completed the square. So then I'm going to be left here with a perfect square, and all I need to do to make that into a perfect square is add something here, which in this case I figured out that that something was this positive 1. So I'm going to go ahead and add positive 1 to this side. But I cannot do it without adding it to the other side as well. So I'm going to also add positive 1 to the other side as well. So whatever you do to one side of the equation, you have to do it to the other side of the equation. Once I do that, I just figured out that, well, this just became my perfect square, which I already factored out as x minus 1 all squared. And then I set that equal to the right-hand side, which happens to be 5. Okay, so when I do that, x minus 1 squared is equal to 5. All I have to do now is solve it. So I take the square root of this side. I take the square root of this side. I get x minus 1 is equal to plus or minus. Don't forget the plus or minus. The square root of 5. And then all I have to do is get the x by itself. So draw the wall, add 1 to both sides. So my two answers are x is equal to 1 plus or minus the square root of 5. Now, these are two answers, right? So we're just lazy and write them as one single answer, but this is actually two answers. X is equal to positive 1 plus the square root of 5, and the other answer, x is equal to positive 1 minus the square root of 5. We're going to check this answer with Desmos and what that means. So when we actually plug this into Desmos, it's going to give me a decimal. So let's figure out what that is first. So first of all, 5, take the square root of that, and then add 1 to it. So that's going to give me 3.23. So my first answer is 3.23. So x equals 3.23. My second answer is 1 minus square root of 5. So I'm going to go ahead and take 5, square root of that, and then take 1 minus that number. So it's 1 minus 2.23. So 1 minus 2.23. Oh, there we go. It's really hard to use the calculator with the easel thing. So negative 1.23 is the other answer. Negative 1.23. So when we plug this into Desmos, right? So I already did that extra step for you. So this is the equation that we had initially, set equal to 0, of course. X squared minus 2x minus 4, which is right here. I plug that into Desmos, and I get this graph, right? So this is a parabola pointing upwards. Quadratic function usually looks like a U, right? There are two roots or two answers. One of them is here, and the other one is there. The first answer is at negative 1.23. The second answer is at positive 3.23, which are the exact same answers that we got, right? So negative 1.23 and then positive 3.23. And the reason why we couldn't think of those answers in the beginning is because this is not factorable, right? If you try to do the x on this, it would not work. So this allows us to solve without being able to use the x. So finding roots without them being particularly factorable. Okay, last example. I know this is taking quite a bit because these are like repetitive steps, but one last example for you guys. In this example, the a is not equal to 1, so we actually have to make sure that we set it equal to 1 first. And in this example, also, we're going to have to deal with fractions. So every now and then we have to deal with fractions, so just don't stress about it. It's just follow the steps. We may have fractions every now and then. All right, so first thing we need to do is make sure that this is in standard form. Okay, it is not, right? I mean, in this case, it kind of is, but we need to make sure that it's in standard form, and we need to make sure that the a is equal to 1. So let's move this. Actually, let's just divide everything by 3, right? We want to make sure that it looks like this, but we want to make sure that a is equal to 1. Since this is not equal to 1, we want to divide everything by 3. That way this can turn into a 1. If I do that to everything, then I'm not really changing anything on the left-hand side or the right-hand side, right? So let's just go ahead and do it. So on the left-hand side, I'm left with x squared minus 2x. On the right-hand side, I'm left with 34 divided by 3. Is that an even number? I don't think that's an even number. I think we're going to have to deal with fractions. 34 divided by 3. No, not even. Wishful thinking. Not going to happen. So let's just leave it at 34 divided by 3. Okay, now the next thing we need to do is complete the perfect square on the left-hand side, because this is now everything on the left-hand side has an x. So, and then everything on the right-hand side has already been moved for me. So now I can actually complete the square. So same steps, I'm going to go ahead and draw that box. On the top left, I'm going to put the x squared. In the diagonals, I'm going to take that number, whatever that number is, and divide it by 2 and put it on each side of the diagonal. In this case, that will be a negative 1x or negative x, same as the last problem. On the bottom right, I'm going to be taking that number, which is negative 1 multiplied by negative 1, and then getting a positive 1 as my result. So that number that I have here, I'm going to add it to both sides so I can complete the square, the perfect square. So plus 1 and plus 1. If I do that, let me get this little box out of the way. If I do that on the left-hand side, I'm going to be left with a perfect square. In this case, that perfect square would be when I factor everything out. Same thing as the last one, right? X minus 1 times x minus 1. So this will be x minus 1 all squared is equal to whatever that is. So I have 34 divided by 3 plus 1, which is really ugly in my opinion. Instead of having this 34 divided by 3 plus 1, I'm going to go ahead and just change that as just 1 to 3 over 3. And by doing that, I'm not really changing anything, right? I'm just basically changing it into a fraction, so I'm able to add. So on top, I'm left with 34 plus 3, which is 37. On the bottom, I'm left with over 3. Since I have the same denominator, I was able to add those two numbers. Okay, now I can move on with the problem. So now I'm able to solve, right? Yeah, we're going to have a fraction, but big deal. Deal with it. So take the square root of this side. Take the square root of this side. I'm left with x minus 1. Oh, x minus 1 by itself. Great. So x minus 1, because the square went away, is equal to the plus or minus the square root of 37 divided by 3. Square root of the whole thing. Okay? Now, I want to move that 1 to the other side. And not only that, I want to rationalize the denominator because this is not considered simplified by any means as of right now. So let's just deal with the rationalizing the denominator part for right now. So I'm going to go ahead and change this into the square root of 37 over the square root of 3. But I'm going to split that square root into plus or minus the square root of 37 divided by the square root of 3. Same exact thing. All I did was split the square root to the top and the bottom. The reason why I did that is I want to rationalize the denominator. So if I want to get rid of this radical on the bottom, I got to multiply it by square root of 3. And if whatever I do to the bottom of the fraction, I have to do it to the top of the fraction as well. So if I do that, I'm just going to drop this down on the left-hand side. X minus 1 is equal to 37 times 3 is going to be 111. So plus or minus 111 square root, all divided by, the square root of 3 cancels out on the bottom. So it's just divided by 3. Almost done. You've mastered fractions by now. So when we add 1 to both sides to get the x by itself, we're basically done. So x is equal to 1 plus or minus the square root of 11, or sorry, the square root of 111 divided by 3. And this is your final answer. And you're wondering, like, what the heck? What an ugly answer. Why did I get that crazy answer? The reason why it's a crazy answer is because it's actually a decimal. They don't write it as a decimal, but let's go ahead and change that into a decimal with a calculator real quick to see what number that actually is. So the square root of 111 divided by 3. So let's do that. So clear everything. 111, 111, square root, and then I take that divided by 3. So I get that number, and then I add 1. So I will get 4.51. So my first answer when I added the 1 is 4.51. Okay, so that's one of my answers. My second answer is I'm going to be taking that number and taking 1 and then subtracting that number from that. So it'll be the square root of 3. Can we do it all in one go? 1 minus... Oh, this is a dumb calculator. It doesn't let me do it. Let's just do square root of 3. So 3 square root of that. Okay. And then take minus 1. Oh, gosh, it's so frustrating. So 3 square root of that. Okay. Minus 1. And then basically make that negative. So that'll give you 0.73. Sorry, I did that math kind of weird. So negative 0.73, 0.73 negative. Anyways, if you have a better calculator instead of using this crappy one that's on my PC, then when you graph it into decimals graphing calculator, what you should be graphing is this last one, which was, what problem is it again? 3x squared minus 6x minus 34 equals 0. So I graph this, 3x squared minus 6x minus 34 equals 0. So on the left-hand side, this is what we should graph. We do that and we get this weird parabola. So it does have roots. So the roots that are graphed are these two roots, which happens to be 4.51 and the negative 2.51. So 4.51 and negative 2.51. Oh, see, I knew I did my math wrong somewhere here. So my calculator is giving me problems, but what was the other one? Negative 2.51. Yeah. If you check it with your calculator, I promise it will give you like the correct answer. My calculator is just being dumb right now. So, anyways, check your work with Desmos if you can. If you have any other questions, let me know. And I hope this video was helpful. See you guys on the very last one.